Yeah, Assalamualaikum and a very good day to all of you. So we are going to continue to the part 2 of electrical science theory. Okay. Okay, so before this, we already discussed about resistor series and parallel. We already discussed about Ohm's law, the diamond shape of resistor series and parallel, terminal voltage, and electromotive force. Okay, charging and discharging of the battery. So now we are going to use one law we call as a Kirchhoff law, which is this Kirchhoff law going to solve the questions where there is going to be three unknown. Okay, mostly it's going to be like three current or three current which is unknown, or maybe two current and one EMF which is unknown. So let's start now. Okay, so what does it mean by the Kirchhoff law? Kirchhoff law basically is consists of two rules. One is for current and one is for the potential difference. Okay, so we have Kirchhoff current law and we have Kirchhoff voltage law. So another name for Kirchhoff current law is we call as a junction rule. Okay, and then for the Kirchhoff voltage law we call as a loop rule. Okay, so Kirchhoff current law state that the sum of all the currents coming into the knot, okay, or we call as a junction in a network must be zero. Or the easiest things that you can actually understand is the sum of the current coming into the point must equal the sum of current leaving the point. So like I mentioned before, example, if you have like junction like this, okay, example, the current going into will be 5 ampere. So the combination here going to produce 5 ampere or so. Okay, that's what you mean by current coming into the knot, which is this one we call the knot or junction, must equal the sum of all the current leaving the point. Okay. So Kirchhoff voltage law state that the sum of the voltage around any closed loop in a network equals to 0. What does it mean by that? Okay, so example, if we have like a resistor, okay, and then you have a voltage here. Okay, so example, if you have 5 volt, okay, voltage we can call it as a potential difference, or if we can actually call as a potential energy. Okay, so what happened is when you have this 5 volt, there's going to be a voltage drop here, R1, R2, voltage drop at R2, voltage drop at R3, which the combination of voltage drop will be equivalent to 5 volt. So it means that, example, the voltage drop may be R1 going to be 2 volt, maybe this is going to be 1 volt and going to be 2 volt. Okay, 2 volt plus 1 plus 2, you get 5 volt voltage drop. Okay, so it means that the algebraic sum of the voltage around any closed loop in a network equal to 0. So it means that you have 5 volt energy, okay, is going to drop at the first R1, is going to drop at the second R2, and is going to drop at the third R3. So the closed loop going to be equal to 0. That's meant by Kirchhoff voltage law. So inside one closed loop, we have the currents, the voltage drop will be equivalent to the voltage given by the battery or power supply. So what happened is going to be 0 inside the closed loop. Okay, this is what I mean by Kirchhoff junction rule, or another name we call as a Kirchhoff currents law. So currents going into the knot, mostly for the currents going into the knot, we put it as a positive. Currents leaving the knot, we put it as a negative. But you can actually put it as a vice versa. Okay, but to make it standardized, current coming into the knot, which is coming into the knot, we put it as a positive. Current leaving the knot, which is this one, is basically leaving the knot, going to be negative. So example, if I need to find the equation for this one, is going to be I1 positive because it's coming to the knot, I2 going to be negative because it's leaving the knot, and then a minus with the I3 because leaving the knot, plus with the I4 because coming to the knot, and minus I5 coming leaving the knot, so equivalent to 0. Okay, so current coming into the knot, current coming into the knot going to be equal to the current leaving the knot. So this is the equations for the first Kirchhoff law. Okay, so for the second Kirchhoff law, which we call as a Kirchhoff loop rule, or another name we call as a Kirchhoff voltage rule, you are going to separate into four. 2 for resistor, 2 for potential difference. 2 for battery means that you only look at the battery. You didn't look at the circuit. You only look at the battery between the terminal. Okay. Okay. So first thing first, when it comes to the Kirchhoff law, example, if I put it like this, okay, example, if you have like this, okay, and then you have like this, okay, one loop, okay, like that, another loop. Okay, so example, this is 5 ohm, this is 2 ohm, and this is 3 ohm. Okay, example that you have, this is for 10 volt and this is 2 volt. Okay, when you have this something like this, you cannot use Ohm's law because Ohm's law can only be used for simple circuit only. But when you have when you have this kind of thing, where mostly you are going to find current, so means that the answer, the question asks to find current I1, current I2, and current I3, and you can see that here this one is parallel to this one and parallel to this one. That's the reason why you get the different current I1, I2, and I3. Okay, so for this kind of question, the first thing first, you need to make an assumption. But here, your assumption always be right, always correct. Okay, but here, the things that might be wrong is going to be the current, the directions of the current that the question give it to you. Okay, so your assumptions always correct, but the directions of the current may be right, may be wrong. So you need to find it. How? Like same as the mechanics part, where if you get negative means that the directions of the I inside the I given by the question going to be wrong. If you get positive, the directions of the current given by the questions is correct. Okay, so means that your assumption always be right, and the current given by the questions might be right, might be wrong. Okay, okay. So what does it mean by assumption? So means that you need to, okay, you need to assume 2 loop. Okay, because we have 1 loop here, and then we have 1 loop here. Okay, first loop and second loop. It can be in the same clockwise. It can be in the same counterclockwise, or you can actually put 1 clockwise or one counterclockwise. Your assumption always be right. Okay, okay. So how to use the Kirchhoff voltage rule? Okay, for you to use Kirchhoff voltage rule, like I mentioned before, you have 2 for the power supply or battery, or you can actually use this also for motor and generator. Okay, for resistor, okay, all the resistor including with the internal resistance, you need to use the rule for resistance. Okay, 2 rule for power supply or motor or generator, another 2 rules going to be for resistor. Okay, so okay, so I put it loop, I called it as a current loop. Okay, for the current given by the question, I call it current inside the circuit, CC. Current circuit is CC, current loop is the one that you assume. Okay, so first thing first, okay, for the potential difference, for the power supply, what you need to look at is the loop. Okay, you need to look at current loop, not current circuit. Okay, current loop. Okay, so for the for the power supply or motor or generator, okay, if your current loop, which is your assumption, moving between terminal, okay, is not inside the circuit, is between the terminal. If moving from positive to negative, from higher potential to lower potential, you need to look sign the output, not the input. So means that moving from higher to lower means that your EMF, your potential difference is going to be negative. Okay, because right now we discuss about Kirchhoff voltage rule. So means that all the equations need to be in voltage. Okay, so means that it's moving from positive to negative, you are going to get negative voltage, because moving from higher potential to lower potential between the terminal. Okay, if your current loop, which is your assumption loop, moving from lower to higher, negative to positive, lower potential to higher potential, we are going to look at the output. So your voltage going to be positive. Okay, these two going to be applied also for the motor and generator. Okay, so what about resistor? Okay, for resistor only, internal resistance also counted inside for this rule. Okay, for resistor, you need to look at current loop, which is your assumption, and also current inside the circuit, current circuit, which is this one is the question given to you. Okay, so you need to look at this. Okay, so for the resistor, if your current loop in the same directions as your current circuit, means that the voltage that you are going to get is going to be negative IR, which is going to be negative voltage. Okay, if your current loop in the same direction with your current circuit, means that you are going to get negative IR or negative voltage, which means that the unknown, the unknown I need to be multiplied by R, then you get this one. And then if your resistance, if your current loop moving in opposite directions with your current circuit, current loop is your assumption, current circuit is the question give it to you. If it's moving in different direction, what happens is you are going to get positive IR, which is positive voltage. Okay, so basically the rule, this is basically the Kirchhoff rule. Okay, there's a if you go further, as there are certain professor or other lecturer that they're going to make it vice versa. Okay, so example like current loop and the current circuit in the same direction is going to be positive. Current loop and current circuit in the opposite direction is going to be negative. But to make it standardized here, plus you are going to use we are going to follow your textbook and also other textbook. So means that this is the rules that we are going to use, where if your current loop and current circuit in the same direction is going to be negative, if your current loop and current circuit in the opposite direction is going to be positive. Okay, so these two resistors also apply for internal resistance. Okay, and for the battery also apply for motor and generator. Okay, so let's start with the questions. This is the things that you can actually clarify your understanding here. So basically what happened here is I3 and I1 definitely you are going to get positive, and y equals to I2 basically it's not going to be like this at the first place. It should be I1 plus I3 minus I2 equal to 0. That's why you are going to get this one. Okay, and for this one, current coming into the node is positive, current leaving the node is negative. So you are going to get for this equation will be I1 plus I2 minus I3 going to be 0. That's why you are going to get this equation. Okay, because the question state current leaving the node and entering the node will be equal. So that's why we're going to be equivalent to 0. Okay, for this one, I1 plus I2 plus I3 equals to 0. That's why you're going to get these questions. In equals to out. Current into equals to current out. Okay. Okay, for this one, I already explained to you, when it comes to the battery, we are going to look only at the current flow, which is this is basically the current loop, or we call it as the current assumption, the assumption current. Okay, so example is if the assumption current moving from positive to negative between the terminal, then you are going to get negative voltage. If your current flow, which is here is current assumption, moving from negative to positive, you are going to get positive voltage. Okay. Okay. Okay, this one also, okay, basically, and this one is for resistor or internal resistor. Okay, so the loop direction is basically your loop direction is your loop direction. Okay, okay, here they call the current inside the circuit is loop, but I think we need to cancel this thing. We call this is current inside the circuit, current circuit, and this is current circuit. Okay, so if the current circuit in the same direction with your assumption, what happens is you are going to get negative voltage drop. If your assumption current and also your current circuit in the opposite direction, then you are going to get positive voltage, which is we call as a voltage rise. Okay. Okay, so this one I already simplified it for you, so you can actually go back and read it. Okay, basically it's the same thing that I mentioned before. Okay, and here, okay, for the terminal voltage and potential difference, please take note, when it comes to the terminal voltage, you need to make sure that you use direction that has been corrected. Okay, so example, if you get negative, okay, so you need to make it so means that you need to find the true direction, whether it's moving to the right or moving to the left. Okay, and then use charging and discharging formula. So here I'm going to show you after this. Same goes to the potential difference. Okay, so I'm going to show you how to use the potential difference and terminal voltage after you use the Kirchhoff law to find the unknown. Okay. Okay, so we start with the first questions. Okay, so when it comes to this kind of question, please take note, your assumption always right, but the current inside the circuit, it might be wrong, it might be right. So this is our job to find whether the directions given by the questions is correct, and we need to find the magnitude of the current. Okay, so first thing first, okay, we are going to have three equations. Okay, so one going to be equation for current, which is we call as a Kirchhoff current law. Another two equation going to be for the voltage, or we call as a Kirchhoff voltage law, KVL. Okay, so we have three equations, and from there we are going to solve for the unknown. So right now the question asks you to find IZ, IS, and IY. Okay, so first step, when it comes to this kind of questions, you need to use the first equation. You need to find the first equation, which is Kirchhoff current law. Okay, so what happened here is you need to choose the node. Okay, basically what happened here is we have two nodes, this one and this one. You need to select only one. Okay, if you select this one, focus only on this one. If you select this one, focus on this one. Okay, so example, if I choose this one as my node, okay, so means that I need to decide, okay, currents going into the node is positive, current leaving the node is negative. So now my equation for the Kirchhoff current law, which is equivalent to 0, will be IS going into the node, so it's going to be IS is positive. IY is basically leaving the node, so it's basically going to be negative. Okay, and IZ is going to the node, so it's going to be positive. So plus IZ equals to 0. Okay, so that is the first equations, which you are going to use later for you to find the unknown. Okay, so next is, okay, you need to make an assumption loop. Okay, Okay, like I mentioned before, you can choose 2 loop in the same direction, or maybe 1 clockwise or 1 anti-clockwise. Okay, but your assumption loop always be right. Okay, so example, if I choose my loop as 1 clockwise, 1 anti-clockwise. Okay, so it's going to be, okay, so this is my first loop and this is my second loop. So that's the reason why I'm going to get 2 equations, because 2 loop. If you have 3 loop, then you are going to get 3 equations. Okay, means that there will be a lot of unknown. Okay, it might be 6. This one you have 3 unknown only. For like 3 loops, I think it's around 6 unknown. Okay, so we are going to find the equation for the first loop. Okay, so the Kirchhoff voltage law state that in the closed loop always equivalent to 0. Okay, so it means that here, okay, IS, this is the area for the IS. Okay, because in series, very good. For the IY, this is the area for the IY. Okay, and then for the IZ, this is the area for the IZ. Okay, as you can see, okay, make sure that you take a correct current. Okay, because IS, IY, and IZ is in parallel. That's the reason why you are going to get different current. Okay, so we are going to solve for the green one and the blue one, which is the first loop. Okay, so let's start. Okay, for the 4 ohm, like I mentioned before, you are going to look at the loop, assumption loop, and also the current inside the circuit. Okay, so means that, okay, so I need to draw it properly. So it's going to be like this. Sorry, it's going to be so it's going to be here, 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 here. Okay, so the black one here, the black here is my assumption loop. Okay, and the red one here is the current inside the circuit. Okay, for the resistor, like I mentioned before, you need to look at the assumption loop and the current inside the circuit. So for the ohms, 4 ohms, as you can see that it move in the same direction. My assumption loop move in the same direction with the current inside the circuit. So therefore, it's going to be negative 4 multiplied with IS, because this value is voltage. Okay, so means that you need to make sure everything is in voltage. Okay, so next, okay, for the 14 volt here, this is potential difference. Look only at the terminal. Please don't ever look at their circuit. Okay, only focus between the terminal. Okay, so means that here you are going to get, okay, you need to focus only on the assumption loop. My assumption loop moving from negative to positive. Therefore, I'm going to get my voltage there will be positive, because to decide the directions, you need to look at the output. Okay, from negative to positive, my assumption loop moving from negative to positive between the terminal. Therefore, I'm going to get positive 14. Like that. Okay. Is there any resistor at the green side? No. Okay, so means that, okay, because it's one loop, you need to take into account this one also. Okay, you need to take into account this one also. Okay, because it's one loop. Okay, so it means that, okay, you go here, okay, you find another resistor over there. So resistor over there, okay, resistor over there, okay, your assumption loop and your current inside the circuit in the same direction. So means that it's going to get voltage what? Negative or positive? In the same direction, is going to get negative. Yes, 2 multiply with which I? IS, IZ, or IY? Is going to be, yes, it's going to be IY, because like I mentioned before, this is the area for the IY. Okay, so minus 2 IY equals to what? Is there any resistor anymore? Double check everything. equals to 0. Okay, so just rearrange. Okay, you are going to get here is negative 4ix minus 2iy. Transfer this thing to here, then you are going to get negative 14. So this is going to be your first equation. Okay, now we need to find the second equation, which means that we need to find the second loop. Okay, so I'm going to use, okay, so means that my loop going to be counterclockwise. Okay, so let's start with the 6 ohm. Okay, my 6 ohm moving, my assumption loop is the same direction with the current inside the circuit. Therefore, my 6 ohm going to be negative or positive? Yes, it's going to be negative 6IZ because this is the area for the IZ. Okay, focus on the 12 volt over there. My assumption loop is moving from where? Positive to negative or negative to positive? Sorry, it should be like that, right? Okay, so from negative to positive, therefore it's going to be, yes, very good, it should be positive 12. Okay, because this one is the because this is one loop, it means that you need to take into account these blue things here. That's the reason why you can solve the unknown, because you have something that actually the same. Okay, so but directions, okay, but here you are going to focus on the directions of the second loop, not the first loop. Okay, the first loop already finished, you need to focus on the second loop direction. Okay, so right now your assumption loop here moving in the same direction with your currents inside the circuit, so it's going to be negative or positive? Yes, it's going to be negative. So negative 2iy equals to what? 0. Okay, but as you can see that even though we have the same iy here, you cannot solve like that because you are still going to get unknown. Okay, so but here I'm going to make it simple here. So negative iz minus 2iy equals to negative 12. This is going to be your second equation. Okay, so basically all the equations that you give it here going to use to find the unknown. Okay, so now, okay, we have the first equation. Okay, negative 4ix minus 2iy equals to negative 14. Okay, this is the first equation, and the second is negative iz minus 2iy equals to negative 12. So this is going to be your second equation. Okay, so I want to change. Okay, so so the next step is, okay, as you can see that in your equations, okay, even though you have the same iy here, but for you to use the simultaneous, you cannot use that. Okay, you need to use the helper, which is helper come from the Kirchhoff currents law. So we have is here, we have iz. Please do not change something that have the same unknown. So right now you have iy and iy. This one you don't have to change. You need to change whether is or iz. Change something that different. Okay, for something that's they have the same unknown, you stay you don't have to change it, but you change some only for the things that different. Okay, so I'm going to change is. Okay, so what I'm going to do here is okay, I'm going to take this equation. Okay, so I'm going to take this equation where I'm going to put is as a subject, which is is going to be iy minus iz. What happened is the third equation here, I'm going to put it inside the first equations. The reason why I'm doing this is because I want to have the same unknown. Therefore, I can solve it using simultaneous equation. Please do not use calculator. Okay, you need to show your working step because working step counted as marks. Okay, so we are going to put it inside the equation 1. So negative 4 iy minus iz minus 2iy equals to negative 14. Therefore, negative 4iy plus 4iz minus 2iy equals to negative 14. So what happened here, make it simplify it, then you are going to get negative 6iy plus 4iz equals to negative 14. So this is going to be, the fourth one going to be your new equation, which you are going to use to solve the using the simultaneous equation. Okay, so I'm going to take the equation 2 and then I'm going to rearrange it. So I'm going to do negative 2iy minus 6iz equals to negative 12. So this is going to be the first. Okay, so once you're done with this, the same thing that you do in mechanics, you can use simultaneous, you can use substitution, or you can use matrices. Okay, so for you to solve it, basically the same thing I already show you in mechanics, where this 6iy you multiply with this, you multiply with this one multiply with this, you multiply with this, and then what you're going to get here is, okay, you are going to get 6 multiplied by 2, you're going to get 12 over there. Okay, 6 to negative 12 iy 4 plus 8ic equals to negative 28. Okay, you only multiply the number, not the sign. Okay, 12, 8 and 14, and then the next one. Okay, and the same thing that you do. Okay, this one you multiply with this one you multiply with this one, and this one you multiply with this one. So you are going to get negative 12 iy negative 36 ic, and that's one going to be negative 72. Okay, so once you're done with this, means that you can find the unknown, where, okay, here minus minus, I'm going to put it as a minus here, so this one going to be 0. So this one going to be 44 iz, and this one going to be, okay, and then this one going to be 44. So basically you are going to get, your answer is 1 ampere. Please make sure that you put the units over there. Okay, once you find the iz, definitely you are going to find the other two, which is iy and the is. So what you need to do here is, you need to put the is into the original one, not the one that you change here. No, you need to put it at the original one. Okay, so I'm going to put it inside the equation 2 for me to find the iy. So I'm going to get negative 6 1 minus 2iy equals to negative 12. So what I'm going to get here is 6. So I'm going to get here is negative 2 iy equals to 6. So basically I'm going to get iy is going to be positive 3 ampere. Okay, so my truth for the iy, the directions given by the question is correct because I get positive. Okay, the positive and negative over there is not represent up and down, up and right. It basically depends, is basically represent correct, right or wrong. Okay, so I already get iz and iy. Definitely I'm going to use this one. Okay, the first, the Kirchhoff current law, the Kirchhoff current law. So for me to find the is minus iy, 3 plus iz is 1. Okay, then you get 0 over there. So my answer is going to be positive 2 ampere. So basically all the directions given by the question is right, but it doesn't mean that you are going to get all positive. It can be one of it is negative, or all three going to be negative. Okay, but if you get negative over here, example, if I get negative 3 ampere, you need to give a statement where, example, if I get negative, so the question given to you, iy is downward, so you should put over there is direction of iy should be upward. Yes, okay, if you get negative. And for you to find IS, if example IY you get negative, we just put the negative inside the equations, because from the beginning you already use the equation that are the direction is wrong. So therefore, for you to find the IS, you need to make sure that you use also the wrong direction, which is negative over there. Okay, if you get negative. Okay, but now as you can see that all answer is positive, it means that all directions given by the by the question is correct. Okay, that is Kirchhoff current law, or this Kirchhoff rule. Okay, so for these questions you are going to get around 8 to 9 marks. Therefore, please show your working stamp, and please do not use calculator. Okay, so let's do this question. Okay, so basically this question is pretty easy, because you only have like 3 resistor and 2 potential difference, 2 power supply. For your real question, it can be like 6 or 7 resistor with like 4 power supply, so it's going to be a little bit complicated. Therefore, double check your equation before you proceed with the calculations. Okay, so let's start. Okay, so now, okay, like this question, they give you a loop, but in your real questions, I don't draw for you an assumption loop. You need to draw your own assumption loop. Okay, so now I'm going to use my, so I'm going to use the same direction, which is one is clockwise, one is counterclockwise. Okay, so for the third one, you can actually use the third one, which is you make a large loop, but I'm not encouraging you to do that. But you can actually use that. Okay, any loop like this one, you use the large loop, acceptable, but I not encourage you to do that. It's better for you to use like this 1 or 2 loop, which is small loop, much easy, and you might not confuse. You will not confuse. Okay, so I'm going to find the Kirchhoff current law first. Okay, Kirchhoff current law first, which is equivalent to 0. So I'm going to use the not at A. You can actually use the not at B. You are going to get the same answer. Okay, so I change. I'm using at B. Okay, this one. Okay, so what happened is my I1 is going to be in this direction, my I3 there, then my I2 here. Okay, so what happened here is I'm going to get negative I1 because leaving the knot. I'm going to get minus I2 leaving the knot, and plus I3 because going to the knot. So I'm going to get this equation, which is this going to be the first equation. Okay, let's find another 2 Kirchhoff voltage law. Okay, so I'm going to start with the first loop. Okay, Kirchhoff voltage law. Okay, so I'm going to start with the 10 ohm. So my assumption loop and my current in the same direction. So I'm going to get negative 10 and I1, because that is the area for the I1, and my potential difference here, power supply, I'm looking only at the terminal, so it's moving from negative to positive. Therefore, I'm going to get positive. Okay, I need to include also with the area of the I3, because this is one loop. Okay, so my assumption loop and my current and the current inside the circuit is the same direction, so therefore I get negative 40 I3 equal to 0. Okay, then I rearrange the equations. Then I'm going to get, here is negative 10 I1 plus 40 I3 equals to 10. This is going to be the first equation. Now we are going to find the second equation from the second loop here. Okay, so I'm going to start from 20 ohm. So my assumption loop in the same my assumption loop in the same direction with my current inside the circuit, so it's going to be negative 20 I2, because that is the area for the I2. And then my power supply here, the battery here, my assumption loop is moving from negative to positive, therefore I'm going to get positive 20. And here I need to include also the R3, because it's basically one loop. Okay, so there my assumption loop and my current inside the circuit in the same direction, therefore I'm going to get negative 40 I3, and it's going to be equals to 0. Okay, rearrange the equations where I'm going to get 20 I2 plus 40 I3 equals to 20. This is going to be my, oh no, this is going to be my third equation. This one going to be my second equation. Okay, so I'm going to use my first equation, which is I get from Kirchhoff current law, for me to find the unknown. Okay, right now you can see that you have the I3, which is basically the same for equation 2 and equation 3, but now the I1 and I2 is different. Therefore, I'm going to change I2. Therefore, I'm going to use KCL. I'm going to the Kirchhoff current law. Okay, so here I'm going to put my I2 as a subject. So it's going to be negative I1 plus I3. Okay, so I'm going to put it inside my third equation. Okay, so I'm going to get here 20 negative I1 plus I3 plus 40 I3 equals to 20. Okay, I'm going to simplify it. So I'm going to get negative 20 I1 plus 20 I3 plus 40 I3 equals to 20. Okay, so my new equation is going to be negative 20 I1. Okay, 20 I1, and then I get plus 60 I3 equals to 20. So this is going to be my fourth equation. Okay, so I'm going to put the equation number 2 there for me to find the unknown, which is I'm going to find the I1 or I3 first. Okay, so here I'm going to put in here. So it's going to be 10 I1 plus 40 I3 equals to 10. So I'm using the concept like I'm showing you before, which is I multiply with this one, and this one. Okay, so I'm going to get here is negative 200 I1 plus plus 600 I3 equals to 200. And then this one, I'm going to multiply with this one, and this one, and this one. Okay, so I'm going to get 200 I1 plus 800 I3 equals to 200. Okay, so I have the same number there, which I can reduce to 0. Okay, so I'm going to get here 1400 I3 equals to 400. Therefore, my I3 going to be 400 divided by 1400. I'm going to get 0.286 ampere, and the answer is positive. It means what? It means that the directions given by the question is correct. The direction, okay, and the magnitude is 0.286 ampere. Okay, now I'm going to find the next one, which is I'm going to put it at the original equation, in the original one, which is I'm going to put it inside equation number 3, which I'm going to get the I2. Okay, so let's proceed. So I'm going to put it inside my equation 3. So I'm going to get 20 I2 plus 40, 0.286 equals to 20. So I2 I'm going to get is 40 times 0.6, 20 minus answer divided by 20. So I'm going to get 0.428, and I'll also get positive. Therefore, the directions given by the question is correct. Okay, 0.428 ampere. Okay, and next I'm going to find the directions for the I1. Okay, so I'm using the Kirchhoff current law, which is basically is much easy. Okay, so I'm going to use this one for me to find the I1. So I'm using that. Okay, negative I1, negative I2, negative 0.428, plus I3 plus 0.286 equals to 0. Therefore, I'm going to get the I1 is 28 plus 6 So I'm going to get the answer is negative 0.14142 ampere. What does it mean by negative here? It means what? Yes, the direction is wrong. The directions for the I1, supposedly here, it cannot be to the right, because negative means wrong direction. Therefore, you need to give the statement here. The direction of I1 should be to the left. Okay. Okay, so I extend a little bit this question. If the question state, find the potential difference from point A to point B. Okay, find the potential difference. Okay, find the potential difference. From point A to point B. Okay, so now if you look at the diagram, okay, you have a lot of paths you can actually choose from point A to point B. Okay, you can actually choose this path. Okay, or you can actually choose A to B with this path, or you can actually choose A to B with this path. Okay, so any path, you are going to get the same value of potential difference because it's a closed loop. Okay, and this is one of the methods that you can actually use for you to check whether your current, the unknown current, is correct, is right or wrong. Okay. Okay. Example, if I want to choose. Okay. I'm going to. Okay. Please make sure that you take two paths because you want to double check. Okay. So if you get the same answer, it means that yes, all the current that you find in the previous part is basically correct, and then that's how you check it. Okay. Okay. So I'm going to use this path. Oh, sorry. I'm going to choose two paths. Okay, which is this one. Okay. And then another path is this one. Okay, I want to check, make sure I'm going to get the same potential difference. So if you use the potential difference, any answer that is negative, you need to fix or correct the direction first before you proceed with the questions for the potential difference and terminal voltage. Okay, you need to choose the directions that already correct. Okay, so now my I1, I get negative here. Therefore, the true direction should be to the left. Okay, so I'm going to use the correct directions. Okay, so I'm going to make one big loop from A to B. Okay, from A to B, and then you use the same rule for resistor and power supply. Okay, but now you already have the value for the I1. Okay, so I'm going to find the potential difference with the green one first. Okay, so I'm going to start with the 10. Okay, my true directions I1 is to the left. So my assumption loop and my correct direction is in the same direction. Therefore, I'm going to get negative 10 multiplied with the I1. I already have the I1 value there. So 0.142. Okay, and then for the battery here, I'm going to look at the assumption loop, which is moving from positive to negative. So I'm going to get negative over there. Okay, so negative 10. So what is the value for this one? So I'm going to get negative 10 times 0.142. Answer this way 10. Okay, I'm going to get my answer is negative 11.42 voltage potential difference. Okay, supposedly if I choose the another path, I still going to get 11.2. The negative and positive over there doesn't affect anything. Okay, but the number you should get the same thing. Okay, if I choose the yellow one, which is this one, okay, from A to B, okay, from A to B. So basically I'm going also do my I3 is correct because I get positive, so I'm doing like the big loop over there. So there's only one resistor over there, so I'm going to get my assumption loop, and my I3 is in the same direction, so negative 40. and then I3 value is 0.286. Therefore, I'm going to get, yes, I get 11.44 negative voltage. Okay, yes, as you can see that you get the same value. Okay, the 0.42 or 44 doesn't affect anything. Basically you are going to get almost close to each other. Therefore, you can actually see state that the current that you find before is correct. Okay, and that's how you find the potential difference. Okay, so the potential difference here, you need to make sure that the directions, if you get negative, fix that thing first, find the true direction, and then you start with the potential difference. Okay, how about if the question asks you to find the terminal voltage? Okay, but this one, there's no internal resistance, so I'm going to show you for the next one for internal resistance, for the terminal voltage. Okay. Okay, so for this one, I want you to do the questions. Okay, and then the question asks you to find the potential difference of point B relative to A. So you can choose any path, but please choose two paths to double check the answer. You can actually choose A to be like this, or A to be like this, or A to be like this, but make sure that you choose two paths to double check the answer. Okay, so I'm going to give it to you the answer in online teaching. Okay, but now you can see that the questions is quite different, where they ask you to find EMF1, EMF2, and current through 4 ohms. Okay, they already give you the current for 1 ampere and 2 ampere. This one you decide by yourself. Which one going to be I1? Which one going to be I2? But I1 and I2 already have the answer. But you need to find the EMF1, the EMF, sorry, this one, no. You need to find the EMF1, EMF2, and EMF1. Basically, you already have 3 unknown, which is same like the previous question. You are going to solve it in the same way. Okay? Okay. Try it, and then I'm going to give it the answer during online teaching. Okay? And then this one also, you find the potential difference. Okay, you try answer the question for this one first. But at the same time, I want you to add up another questions, C. Okay, find the terminal voltage, okay, for each battery shown in the figure. Okay, so means that you need to find the potential difference for this one. Find the terminal voltage for this one, this one, this one, and this one. You have 4 terminal voltage. Okay, but please, for the terminal voltage is the same like potential difference, where you need to find the true direction first. Okay, and then from there you are going to know whether it's charging or discharging. Okay, so you are going to use the formula, because terminal voltage is all about power supply. So you need to use VT equals to EMF minus IR for discharging, or VT equals to EMF plus IR. Okay, but make sure that you use the correct direction first. Correct direction, where if you get negative, fix the direction first, then you know whether it's charging or discharging. Okay, you are going to look whether it's moving from positive to negative in the circuit for discharging, or negative to positive in the circuit for charging. Okay, and then we are going to discuss it during online teaching. Okay, that's all from now. So I'm going to see you during online teaching, and then we are going to have the one last chapter, which is thermodynamics. Okay, so if you have any question, feel free to ask. Okay, and that's all for now. Okay, assalamualaikum and goodbye.